derivative with respect to y. What's the derivative with respect to y? Cosine of x. Cosine of x is actually a coefficient of y. So it's y to the first power times some number. That number is represented by cosine of x. So zxx, the derivative of this with respect to x, will be negative y cosine of x. The derivative of this with respect to y, what are we going to get? We'll get 0, because there are no, there's a y. And then zxy, I could take the derivative of this with respect to y, or I could take the derivative of this with respect to x, and I would get the same thing, minus sine. Much quicker and cleaner than the last two that we did. But we end up with some interesting things to recognize in terms of if you're finding your critical points, again, you look at your first derivative, so you look at these two. So z sub x would be 0 if y was 0, or if sine of x was 0. If sine of x is 0, then x has to be some multiple of pi. Remember, sine is 0 at 0, at pi, at 2 pi, at 3 pi, at negative pi. For z sub y to be 0, cosine of x has to be 0, and that means x has to be an odd multiple of pi over 2. So let's step back and think about this a minute. Okay, for z sub x to be 0, y could be 0. Or sine of x could be 0, meaning x would have to be any multiple of pi. But critical points mean both are 0. Both of these have to be 0 for it to be a critical point. So for z sub y to be 0, I have to have x's fit this pattern. Otherwise, z sub y is not going to be 0. So I have a whole bunch of critical points. I technically have infinitely many. But I suspect the same thing happens at all of them. If x is any odd multiple of pi over 2, and y is 0, then this will guarantee that z sub y, this ends up making z sub y 0, and this ends up making z sub x 0. So those are my critical points. If you organize D, D is z sub x, z sub double x times z sub double y, but z sub double y was 0, minus z sub xy squared. Okay, so that ends up turning into 0 minus sine squared. And so negative sine squared is always negative. So if, no matter what you even plug in for x and y, if d is always negative, what does that tell you occurs at every one of my infinitely many critical points? Saddle points at every one. Thus, saddle points at all points where x is some odd multiple of pi over 2, y is 0, and then z would be Z would end up being 0. If you plug these into your original function, Z is gonna be 0 because both Y being 0 makes it 0, but then also odd multiples of pi over 2 make that 0. And so if we look at our graph, we can kind of identify these points. Y is 0, so I think this would be the x-axis, this I think is the y-axis. And so like right here, you can see like right here is one of those saddle points that I have concave up in this direction, but then I have concave down in this direction. Let me try to dim the light real quick. Okay, so this direction is y, and this direction is x. And so right here is one of the critical points, because I have concave down in that direction and concave up in that direction. And then here's another saddle point, it is on this axis, so concave down in that direction and concave up in that direction. So as the paper kind of twists, where you're twisting it, you're creating those saddle points.
It kind of looks like, maybe it's the angle of the graph of that, but it looks like those saddle points aren't actually like exactly lining up with the x and the y.
Well, I think
either.
that's because it's tilted this way.